Okay, now that we're familiar with the disturbance term, and you'll recall it ui equals yi minus the expectation of y given xi from the last video, we can start leaning into this idea of omitted variable bias. But what I want to first demonstrate or build off of was this idea that when we had a sum of those ui observations, those would actually go to 0. And so when we'd sum them, they would go to 0. And what we could say is, in essence, we had some sort of a set of error terms out of our various individuals. That was Tom, Bob, and Ava. So we had a full set of UIs. So the expectation of UI, given their xi, in our case, that was 12, equals 0. So that was to say that if you had the expectation of ui given that x equals 12, we had seen, at least with them, that the expectation would have been equal to 0, because even if I take this and then divide by 1 over n, that would be irrelevant. It wouldn't really matter, because we'd be, you just multiply out that n, and the key here would be you would retain that 0. So now I want to generalize this. So I want to show a generalizable algebraic proof for this. And this is to say, so I'm going to anticipate omitted variable bias. This is saying that we don't have any omitted variable bias. So in general, this is what we would expect. And so we could take an expectation operator, a conditional one, on the condition that we are given some xi value, and we can apply that to the left hand and the right hand sides. So what we're going to do is basically everything that goes in here, that what's in the parentheses here on the right hand side is going to go in there, and what's on the left hand side goes in there as well. So we have the expectation of ui given xi, and then we would set that equal to the expectation of parentheses yi minus the expectation of y given xi, and then close parentheses given xi, because again we're taking the expectation operator. It's a conditional expectation operator, because we're taking this on the condition that we're given some xi value. So now, I want to focus on the right hand side and simplify. So I'm going to distribute the expectation given xi, because that's basically what's being distributed into the parentheses here. And we're going to split those terms. So that's all that's going on. So that would be saying the expectation of yi given xi. So that's this and then this, just attaching. And then we're going to do the same thing and attach this subtracting expectation of y, given xi. So that would be minus then the expectation of y given xi, and then given xi, because again we are taking a conditional expectation given xi. Now don't freak out about this. It's okay. So y given xi, you're probably thinking, okay, we got a given xi and then we've got the expectation of y given xi. I don't know what to do, what's going on here. It's actually nowhere near as big of a deal as you'd think. So recall perhaps back to early algebra where y equals 2x. And then let's say we were given that x is greater than 3. So we only have this function given x is greater than 3. So we go, okay, great. So I could be like 3.01, that's fine, and so on and so forth, on to infinity. But I just can't be below 3, or even equal to 3. And then I were to say also, given x is greater than 3. That's really ridiculous. So don't worry about this, because if you say it twice, it doesn't matter. As long as you say it one time, the condition holds. You could say it an infinite number of times, but you only need one. So pick one, erase the other. As long as we've already stated given x is greater than 3, then that's what we use. And it's the exact same way with these expectation operators. So if we have multiple givens, it's literally the same thing as saying the expectation of y given xi, and then just close the bracket. Get rid of that other given. We've already accounted for it here. And if we take an expectation of an expectation, we've seen that before. This just simplifies to the expectation of y given xi. That's it. So, done on this portion of it. Now we're still subtracting. Come over here. We got one little teensy-weensy thing we got to edit. When this says the expectation of yi given xi, think about Tom again. If I'm saying y, the expectation of y, so even if it has the subscript I, so that would just be like, what's the expectation of, in this case, I would be, you could say it's T for Tom, because Tom is the individual of concern. Well, what is the expectation asking for? It is not asking for his actual wage. It's not asking for that. It's asking for the expectation of his wage given his level of education. And that's literally the same thing as just saying the expectation of y given xi. Because given Tom, we still wouldn't say, okay, this is $36,000 a year. No, his expectation was $44,000 a year. So that actually can be translated directly back to just y given xi. And then these go to 0. So that is to say, we can set our expectation of ui given xi equal to 0. Because we've algebraically demonstrated that. Now again, this is predicated on us having all of the relevant information. And so we'll see as we move on in our video series here that this condition will start to break down. But this is our target, and this, at least mathematically, especially if you're taking this out of a sample where you have all of the relevant information, and not just that, you could actually have all the relevant information in a population and still run into omitted variable bias. So that'll be a key distinction for a later video. But the main takeaway that I want you guys to have in this is just to understand that, okay, now if this is what we expect and we can mathematically demonstrate this, then the expectation of just u given any and all x's equals 0 as well. And so this is our expectation, and this is what we would call the unbiased condition. And bias will actually enter in a very sneaky backdoor way. It'll actually circumvent our sort of our algebraic wall that we've built for ourselves. So, and it'll make sense as we move along. But I have to at least introduce you guys to this, and you can see where this is coming from algebraically. So, for now, don't worry. We're building scaffold. Well, we're building towards our end goal, and so it's kind of scaffolding, but also kind of actually really necessary for you to understand this in econometrics in general. So with that, I'm gonna cut this video out, and we'll just keep going with this next time.